So we've delved into the mysteries of the threads and all of the geometry that we're dealing with the inclined plane. And what that means for us in our mechanical design is we have a couple of options. So in the video, I got ahead of myself a little bit and added the cosmetic thread because we did an example with the 12, we did an example with the 10. And so whatever we generate for the internal thread, we need to also make sure it aligns with the external. So the two most common for a M10 is a pitch of 1.5 and 1.25. And then for a metric 12 millimeter, or is the 1.75 and the 1.25. All right, there may be other classes available or other pitches available, but we have to pick one. So let's go back in and we will open up for the lock pin was the M10, and so in the drawing I went ahead and added it as a cosmetic thread, and if I edit the feature I can see that I made it an M10 by 1.25. When I go back to the chart and look at the 1.5, that being a larger number, the crest to crest distance or the root to root distance is larger. That is a coarser thread, and the 1.25 then is a finer thread. And then it would be the same M12 by 1.75 coarse, and 1.25 is the finer. So we added that as a cosmetic thread, and just that's going to be the most common. What that does for us is a simplified thread form. We can see the minor diameter where it terminates, and that gives us enough information that in the drawing we'll be able to decipher those geometries. And if I rotate over, the other thing that we can do, and I usually recommend that you do this as a configuration. So if I were to suppress the cosmetic thread, the other method, and this has gotten quite a bit better in the last couple versions, is to go with, underneath the hole wizard is a thread feature. From let's see, that doesn't just the warning that these are going to be close, but don't rely on them for if you're doing a 3D print, you're going to have to play with it basically. So the end condition, we had 15 millimeters for our length. This pulls up an odd 80, and I don't know why it defaults to odd 80, but on a really big part with a really big thread, that is really annoying. So we're going to go with external would be a die. The die is the tool that as we turn it around the part is cutting the threads, or most commonly cutting the threads. And then we can also single point on a lathe or in a CNC single point, which is a tool traveling across that face in a repeating fashion till it generates the geometry. The tap then is what we're going to do to cut internal threads, and we select the taps and the tap drill based on the chart and the information we just went over to create our either the mating geometry or picking out a nut. So this one was the M10 by 1.25. Notice there is a 1.0, 1.25, and a 1.5. So if I go to the 1.25, this is a cut thread. It's going to kind of generate that helix, and there should be, it is a right hand thread. We have a 0 degree starting point, not that it's really critical, but it is kind of nice to know where it is originating. And then I like to do an offset because if it starts right at that edge, then the geometry usually ends up with a little extra. Let's just go select 2 millimeters, and then I'm going to reverse it. so that it comes completely off of the part rather than leaving a little triangle in that area. Cut cylinder on a cylindrical surface. Use extrude. Okay, so, cut thread and then extruded thread. All right, so let's go with the extruded thread. Oh, that went to the outside, so that wasn't quite what I wanted. So that was showing an external. And I was looking for it to, well, I actually did want it to cut. So I have to pay attention because after talking about the die and the tap, I picked the tap. And so with a die, you're going to have a cut thread, and with a tap, then possibly you would have an extruded thread, whether it was internal or external. Looking down, since we're here looking down through the rest of the options, multiple starts, you can have fast leads, so a double, triple, or quad thread lead will basically have the multiple start. Let's see, trim with start face, trim with end face. I think those are maybe new, so I'll have to look into what the definition. I don't think there's a tooltip for that. So I would think that it would be what I'm trying to avoid by extending this out, offsetting it out a little bit. Okay, so that gives me thread, and notice that the thread just kind of terminates, and when we're turning this on a lathe with a die, there is kind of a swoop out of the part. So that gives me the thread. If I suppress that one, then there is the traditional cut swept, which we end up drawing the geometry. So if I go in and create a sketch, this is a sweep is 2 parts, and this is going to be a little more complicated. So I want to just start on the end face and convert. So I missed it, so let's see if it's popping up there. Sketch tools, convert entities. All right, so that'll work. So that gives me a base circle, and then I have to determine the helix that I want to cut. So that base circle, going back into the features, going into curves, and generating a helix or a spiral. Now let's go ahead and reverse the direction. The pitch is 1.25. And am I going to do pitch and revolutions, height and revolution, or height and pitch? Well, I have the pitch and I have the height, so 15 millimeters. And starting angle will stay with 0 degrees. So in this case, because the planes intersect at 0, 180, and 270, I would stay with those. I'm going to make it a little easier to figure out where it starts from. So if I go to 3, I can kind of see it tapers off and ends over here. And we'll end up in drawing the V for the thread in that attached to that geometry. So looking for the plane that intersects at that point, we'll go ahead with the sketch. It reversed on me, but that's okay. I can still see that it ends down here. Generate a line, and depending on what I'm trying to create, we'll go ahead and put in a center line. So I just have it for reference. I'm not going to worry about the root radius and the crest, the flats on the crest. So we can go ahead and put in that geometry and make sure that it all ends up in there. But I think for our purposes, the sharp V always gives us a good indication, especially if it's a strange or oddball thread. So we had 1.25 millimeters as our pitch. We're going to go ahead and put in the 1.25, but I might want to make that 1.24 because swept cuts have a tendency that if they overlap or intersect, they will fail. So pick a point, or a point, and I want to again be kind of off the part, I extended this past the chamfer. It just kind of depends on if the chamfer is already there or not. All right, so it didn't give me a usable relation. So if I pick the curve and the point, coincident allows for several solutions on this, where Pierce says the plane that intersects the curve is only going to happen at two spots, one over here and one over here. And technically we could follow those points up, but if it goes to the closest one, that generates my geometry. All right, so I told this to go 15 millimeters. This is going to overrun a little bit because I picked the mid, but I'm still okay with that. So we have the curve and we have the sketch, so a profile and a path. Features, swept cut. If I've done this correctly, it will come up with the sketch profile. Circular profile is new, solid profile, so it looks like I have some studying to do. And I'm not getting a preview, so definitely want to double check. Okay, so the profile is sketch 8, and the path is showing it as edge 1, which highlights correctly, so I'm not getting much of a preview, so we'll take our chances and go ahead and hit OK. Usually, operation failed to complete. So as I mentioned, because where this point, when it comes around, would intersect with this point up here, we can't really do that and have SOLIDWORKS be happy about it. So if I take off 0.1, which is about 4 thousandths, and we'll go ahead and rebuild that and try again. Features, swept cut, and now I get the yellow preview with that in place. I expect that will work. All right, so I can hide the helix, and then we can go back through and verify. So one of the things I like to do if this were a something I was going to try to 3D print or have a little more in the geometry would be to open a sketch and convert that geometry. Okay, and then features, revolve cut, its axis of revolution. And then it doesn't just terminate squarely, it kind of shows a lead out, which is maybe a better representation. So when I want to see what these can do, we will suppress, and this is why I mentioned the configuration. If I unsuppress the unsuppress the thread, then I get that. And this has a little bit more of the crest flat and the root, but it's not really a radius. And then we go back and suppress that. And then hide show the cosmetic thread. Keep in mind that with the cosmetic thread, you have to be looking end on. So did I suppress that or show that? There we go. All right. So the cosmetic thread doesn't really mind if it's just more geometry if the cut swept is unsuppressed or the thread is unsuppressed. It's kind of confusing. So well, the reason that I want the cosmetic thread then is if I come over here, let's go ahead and unsuppress that one. We'll go ahead and hide the cosmetic thread, make sure that's saved, and I'll go back and open my drawing. And even though these look nice, they take up resources to calculate all those little triangles and that shape. And when it comes over to the drawing, it skews my numbers a little bit. And even though it looks nice, it doesn't really add a lot of value to the information. So maybe I could put it in the isometric. If I had the configuration, I could put it in the isometric, but it really hasn't helped me any with the drawing. So just some things to keep in mind, that if it's necessary, If it adds value, then go ahead and place it. And I think I hid the whole body. So let's go ahead and check. Yep, I hid the body. So I want to suppress, and then I want to show, and then we double check it by looking to the side or from the end so that we see the minor diameter inside of the thread. So you have to decide what value this has for you and how much effort you want to put into having that detail.